Hello students, welcome to EPG Pathshala. Today we are going to discuss the module water softening. In this module, we are going to learn about the hardness of the water, the causes of the hardness of water, what are the permissible limits for the total hardness, as well as the various methods or the treatment ways by which the hard water can be converted into the soft water. Now, the softening of water, it is a technique in which the ions which are contributing toward the hardness of the water, they are removed from the water. Now, question comes, what is the hardness of the water? The hard water, it does not generally form the leather with the soap. Instead of that, it forms the curdy scum with the soap. And this hardness of the water, this is the property because of the presence of the divalent cations like calcium ions, magnesium ions, strontium ions and the anions like chlorides, bicarbonates and sulfates. The groundwater is having more of the hardness as compared to the surface water. The permissible limit of the World Health Organization for the drinking water is the permissible limit is 500 mg per liter of the hardness and the desirable range is 100 mg per liter. The groundwater is having more of the hardness as compared to the surface water. The surface water is having the hardness of the range of 100 to 150 mg per liter. That is why no softening procedures are required for the surface water, but as the hardness level in the groundwater is more than 1000 milligram per liter, the softening processes they are needed for the treatment of groundwater before they can be used for the drinking purpose. And the hardness of the water is expressed in the terms of mg per liter of calcium carbonate equivalent. Now, in this module, we are going to discuss about the different kinds of hardness, the temporary hardness and the permanent hardness, and also the different treatment procedures for the removal of the hardness. The term hardness was originally applied to waters that were hard for the purpose of washing. It means they are not forming the foam with the soap. The hardness property of the water prevents the soap from lathering by causing the development of an insoluble curdy precipitates in the water. And this hardness typically causes the buildup of hardness scale, which can be very easily seen in the cooking pans which are used for the boiling purpose. The dissolved calcium and magnesium salts present in the water are primarily responsible for most of the scaling in the pipes, water heaters and cause numerous problems in the laundry, kitchen and bath. The hardness is usually expressed in grains per gallon or parts per million as calcium carbonate equivalent. The hardness of water is caused mainly by the salts of calcium, magnesium and the anions bicarbonates, chlorides, sulfates and nitrates. The positive electric charges of these cations are balanced by the presence of the negative anions, and these ions they are having their origin from the sediments or the rocks in which this groundwater comes into contact, and the carbonates which are present in the water, they are as a result of the contact of carbon dioxide which is present in all waters which are exposed to the atmosphere. Now, let us discuss the origin of hardness in the water. The carbon dioxide present in the atmosphere reacts with the water to form carbonic acid, which exists mostly as bicarbonate ions in the environment. Microscopic marine organisms take this up as carbonate to form the calcium carbonate skeletons, which over millions of years have built up into extensive limestone deposits. The groundwater, which is slightly acidic by carbon dioxide, dissolves this limestone, thereby acquiring the calcium and the bicarbonate ions and becomes hard. If the bicarbonate concentration is sufficiently great, it causes calcium carbonate to precipitate out on the surface as the inside of the pipes. Now, you can see in this slide that carbon dioxide which is present in the atmosphere, it reacts with the water to form the carbonic acid, and this carbonic acid it dissociates to form the bicarbonate ions, and these bicarbonate ions they are in equilibrium with the carbonate ions. At the low pH towards the acidic pH, that is at around 4.5 pH, the bicarbonate ions predominates and it will result in the formation of the carbonic acid, and toward the alkaline pH the formation of the carbonate ions is favored, which will precipitate out along with the calcium to form the calcium carbonate, which gets deposited as a scale on the pipes. Generally, water containing more than 100 mg per liter of hardness, which is usually expressed as calcium carbonate equivalent, is considered to be hard. The excessive hardness is undesirable because it causes the formation of the soap curd, increases the use of soap, deposition of scale in the boilers, pipelines and home appliances. It also damages the industrial processes and can cause objectionable taste in the water. Now, let us classify the water based upon its hardness. Water having up to 45 mg per liter of calcium carbonate equivalent is extremely soft to soft, and the water which is having hardness in the range of 46 to 90 is moderately hard. Water having the hardness beyond 100 mg per liter of calcium carbonate equivalent is called hard water, and the water which is having over 250 mg per liter of equivalent calcium carbonate is too hard and it is not fit for the domestic purpose. Now, let us discuss the types of water hardness. Water hardness is divided into two types. The one, temporary hardness, which is also called carbonate hardness. This refers to the hardness whose effects can be removed by boiling the water in an open container. Such waters have usually percolated through the limestone formations and contain the bicarbonates of calcium and magnesium along with small amount of carbonate. Both calcium and magnesium bicarbonates decompose when the water is boiled. So, boiling of the water promotes a reaction and the carbon dioxide which is evolved, it leaves the water. So, the carbonate reacts with calcium or magnesium ions to form the insoluble calcium and magnesium carbonates, which precipitate out and forms the scales on the surface. Thus, the calcium and the magnesium ions are removed from the water and so is the hardness. Therefore, hardness due to bicarbonates is said to be temporary. The another type of hardness present in the water is called the permanent hardness, and this hardness is contributed by the non-carbonate anions. The water containing other anions such as chlorides or sulfates cannot be remediated by boiling and it is said to be permanently hard. When measuring the hardness, we typically consider the total hardness, which is the sum of all hardness compounds in water expressed as calcium carbonate equivalent. The total hardness includes both temporary and permanent hardness caused by calcium and magnesium compounds. Now, we had learnt about the causes of the hardness in the water. Let us discuss about the procedure for the softening of the water. Water softening is the removal of hardness from water. This is not required as the part of the water treatment process, since the hard water does not have any health consequences. In fact, the National Research Council states that drinking water generally contributes to the total calcium and magnesium needs in the human beings. However, the hard water is problematic for a variety of reasons. Hard water makes soap precipitate out of the water and lead to the formation of the scum, such as the ring which form around the bathtubs. In addition to this, unsightly, the reaction of the hard water with soap results in excessive use of soaps and detergents. Hard water may also cause taste problems in drinking water and also shorten the life of fabrics washed in the hard water. Finally, we can say that this hard water harms many of the industrial processes. So, industries often require much softer water than is required by the general public. Excessively hard water will nearly always have to be softened in order to protect the water treatment plant, equipment and the piping system. At a hardness level of greater than 300 mg per liter of calcium carbonate equivalent, the scaling will take place. That is, the white deposits can be seen on the inner walls of the pipes as calcium carbonate precipitates out of the water. Processes for water softening. The first process is chemical process, including the lime soda process. The process of water softening involves the addition of chemicals like calcium hydroxide and soda ash. This soda ash is sodium carbonate and they are used to make the hard water softer. There are two modifications. One is cold lime soda process and the second one is hot lime soda process. In the cold lime soda process, the raw water and the calculated quantities of lime and soda, they are mixed with the water at room temperature. At room temperature, the precipitates formed are finely divided, so they do not settle down easily and cannot be filtered easily. At the room temperature, calcium bicarbonate present in the hard water along with calcium hydroxide, that is lime, forms calcium carbonate. Similarly, magnesium bicarbonates also form magnesium hydroxide and calcium carbonate, and the non-carbonate calcium hardness can be further reduced by adding the sodium carbonate. The calcium chloride, it reacts with sodium carbonate as we can see on the slide, and it will lead to the formation of sodium chloride and calcium chloride. This reaction is having the optimum pH at about 10 to 11. This pH can be obtained by using the additional lime. These precipitates are then removed by the conventional process of coagulation, flocculation, sedimentation and filtration. Because precipitates are very slightly soluble, some hardness remains in the water, which is usually about 85 mg per liter of the calcium carbonate equivalent. In the process, it is essential to add small amount of coagulants like alum, aluminium sulfate, sodium aluminate, etc. These coagulants hydrolyze to flocculant, gelatinous precipitates of the aluminium hydroxide, it entraps the fine precipitates. So, as a result of that, the precipitates will lead to the flock formation, and use of sodium aluminate as the coagulant also help in the removal of silica from the water as well as the oil if it is present in the water. This process provides water which is having the residual hardness of the range of 50 to 60 ppm. In the hot lime soda process, the treatment of the water with the softening chemicals is done at a temperature of 80 to 150 degrees Celsius. Since hot process is operated at a temperature close to the boiling point of the solution, so the reaction proceeds much faster and the precipitate formed settle down rapidly, hence no need of adding the coagulants. This process produces water of comparatively lower residual hardness, and the residual hardness of the water after the hot lime soda process is in the range of 15 to 30 ppm. After softening, the water will have the pH and will have the high pH and contains the excess lime, and the magnesium hydroxide as well as the calcium carbonate present in the water that has not precipitated is also a problem. So, recarbonation, that is adding the carbon dioxide, is used to stabilize the water. The excess lime and magnesium hydroxide are stabilized by adding this carbon dioxide, which also reduces the pH from 10.8 to 9.5, and the reactions, they are shown on the slide. It is not possible to remove all the hardness from the water. In actual practice, about 50 to 80 mg per liter of calcium carbonate equivalent hardness will remain as the residual hardness after the treatment of the hard water through this lime soda process. Let us discuss the advantages and disadvantages of lime soda process. This lime soda process is a very economical process, and if this process is combined with sedimentation or coagulation, the lesser amounts of coagulants shall be needed. Further, the process increases the pH value of the treated water, thereby corrosion of the distribution pipes is reduced. Besides removing the hardness, the quantity of the minerals in the water is also reduced by this lime soda process, and this lime soda process to certain extent also removes iron and manganese from the water, and due to the alkaline nature of the treated water through this lime soda process, the amount of pathogenic bacteria in the water is also considerably reduced. But the disadvantages of this lime soda process is the disposal of large amount of sludge which is formed is a problem, and this lime soda process can remove the hardness only up to 15 mg per liter, which is not good for boilers. For efficient and economical softening, careful operations and skilled supervision is required in the lime soda process. There is also another process for softening the hard water, and this process is ion exchange process. This ion exchange process fall into several categories. The first category is softening. In this process, the both carbonate and non-carbonate hardness is removed, and the water is usually having the high non-carbonate hardness, with the total hardness is less than 350 mg per liter of calcium carbonate equivalent. In the ion exchange softening processes, calcium and magnesium ions, they are exchanged for sodium ions. However, the ion exchange softening has its disadvantages also. The calcium and magnesium present in the hard water are replaced by sodium ions, which may cause problem for the people which are not supposed to eat the salt. The softeners have to be backwashed in a manner similar to the filter, and the recharge water, which is a brine solution, can also cause a disposal problem. The second category is demineralization. In this process, the hard water is passed through the ion exchange resins, which are insoluble, cross-linked, long-chain organic polymers with microporous structure, and the functional groups attached to the chains are responsible for the ion exchange properties. Ion exchange resins can be classified as either cation exchange resins or anion exchange resins. Cation exchange resins, as the name suggests, are exchanging the cations present in the hard water, mainly styrene, divinylbenzene copolymers, which after sulfonation or carboxylation are used as the cation exchange resins, and they become capable to exchange their hydrogen ions with the cations present in the hard water. The anion exchange resins. Anion exchange resins are styrene, divinylbenzene copolymers which contain amino or the quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups as the integral part of the resin matrix, and these after treatment with dilute sodium hydroxide solution become capable to exchange their hydroxyl ions with the anions present in the hard water. The hard water in this process is passed first through the cation exchanger resin, and after all the cations contributing toward the hardness of the water are removed, the water is then passed through the anion exchange resin. This anion exchange resin remove all the anions like sulfate, chlorides and nitrates present in the water with the equivalent amount of hydroxyl ions, and then the water is released from the column. These replaced hydrogen ions and hydroxyl ions combined to produce the water molecule, and the water coming out of the exchanger is deionized or demineralized water. When the capacities of cation and anion exchangers to exchange hydrogen ions and hydroxyl ions respectively are lost, they are then regenerated. The cation exchange column is regenerated by passing a solution of dilute HCl, and the exhausted anions exchange column is regenerated by passing a solution of diluted sodium hydroxide. After this ion exchange process, the another method for the softening of the water is the membrane process, commonly known as reverse osmosis. Membrane technology is a widely accepted means of producing various qualities of water from the surface water, well water, brackish water and sea water. In the treatment of water for drinking purpose, first of all, the pressure driven membrane techniques are used. The choice of the suitable membrane process depends upon the size of the removed contaminants and admixtures from the water. In the normal osmosis process, the water naturally moves from the area of low solute concentration through a membrane to an area which is having the high solute concentration. But with the application of an external pressure, the natural flow of the water can be reversed, which is nothing but reverse osmosis. The removal of minerals occur at the osmotic membrane chamber. that usually has tiny pores that can only allow water molecules to pass through. The pressure is around 35 to 40 pounds per square inch, and this pressure is applied to push the water molecules across the concentration gradient. All other substances like calcium ions, magnesium ions, chloride ions, sulfate ions, nitrate ions, they are left behind and the softened water is produced. This is an effective method of both water purification and softening. The only disadvantage associated with this process is the use of electricity and wastage of a lot of water during the purification and softening process. So, students, in this module, we had learned about the different causes of the water hardness, the various cations like calcium, magnesium, manganese, ferrous ions and the anions like chloride, carbonate, bicarbonate, sulfate and nitrates, which are responsible for the hardness of the water. And we had also learned about the temporary hardness of the water, which is mainly because of the presence of the carbonates, as well as the permanent hardness of the water, which is the non-carbonate hardness. In this module, we had also learnt about the different methods for the water softening process. One method we had learnt is the lime soda process, second method we had learned is the ion exchange process, and the third method we had learned is the membrane process, also commonly called reverse osmosis. Thank you.